It's time for pure performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, we have with me Andy Grabner, my co-host. Andy, how are you doing today?
Hey, Brian, I'm good. Just came back. Well, I know at the time when this records, we just came back from NEOTIS PAC in France.
Yes. I was very jealous about that. Yeah. I saw you all getting your renting some ski equipment at one point, I think.
We did in the afternoon of the last day, so that was really great.
Yeah, well, I guess I can't complain. I do live in Denver, but yeah, I'd never been to the Alps. That looked really awesome. I'm also really excited today because I have a real nice delivery coming from Sweetwater, some new audio gear. So I'll get back to some recording. Going to be able to record my drums again. And so it's a good day, and it's a good day for other reasons, right? We have a good guest today, Andy. Do you want to?
Yeah, we do actually. And I think it's been, and I need to ask him when we met the first time in Poland, Konrad. He is an author of a book called Pro.NET Memory Management. And I think memory management is a big topic for most of our customers. And therefore I was excited that he actually reached out to us again and said, hey, we met a couple of years ago. Do you want to talk about this topic? Is this interesting? So Konrad, maybe you want to take it away from here and maybe introduce yourself, and then we'll get started.
Sure. Hello, everyone. As you said, I'm Konrad. I'm living in Poland. As you said, also I'm author of this book, huge book, because it's over 1,000 pages.
Wow!
I remember that we met in Warsaw. We were talking, Andreas, about web performance in a meetup which I was organizing then. And I remember that I was saying that I'm just starting to write this book. It was, 3 years ago. So. And a few months ago I finished, so indeed it took me over 2 years to write it. And as you said, I'm a consultant, a freelancer, .NET related. I'm giving trainings, I'm doing consultancy also on the topics related with the performance and architecture. And this is my everyday job currently. And as I said, I finished this book a few months ago, and now I'm trying to, let's say, gather the feedback from the market.
Well, congratulations on completing the book. That sounds like a massive book, but I'm sure there's plenty.
Yes, it weighs 2 kilograms.
Wow.
Is this a measure of is this something that you authors internally measure yourself against? Like, how heavy is your book?
It was not, but since my book, I just a lot of people was just having fun from the size of this book. When the book was published, people were publishing on the Twitter, for example, tweets with the photo of this book saying what it is, why it is so big, and so on. And why there was even one tweet when someone weighted it. So from this, I know that it is 2 kilograms.
Well, it puts you up there with Herman Melville and Leo Tolstoy as far as sizes go. So congratulations, you're in good literary company.
Yeah. Hey, so Konrad, now let me ask you a question. I remember when I was doing more active .NET development, everything was so easy in .NET. At least they made it seem, because there was not a whole lot of things you could actually change and configure when it came to garbage collection, heap sizes, all the stuff we knew from the Java side, how you could configure and size and tweak memory management, garbage collection. This was all really not there, and obviously this was years ago. So let me ask you, why does somebody need to write a book for 1,000 pages, and why does somebody need to read a book? What are the challenges now? What has changed over the last couple of years, especially in modern .NET environments?
It's a very good question. In general, this book has been written after more than 10 years of .NET existence. So this by itself says that it was not very needed because .NET was very good without without such a book. Because as you said, .NET is very convenient in writing, but mainly because such things like automatic memory management. So a lot of people doesn't have to care about it in most cases. We can say, for example, that 18% of development should not be very aware of .NET memory management. But still there are some cases, like 20% of cases, when things are not going very well, and we should start to think about it. So in general, to answering your question, .NET memory management is still very good, and it doesn't have to be fixed in any way, and this book is not an answer to such needs. Simply, I think that after so many years of .NET development, we gathered some patterns, some anti-patterns from experience of people related to .NET memory management. There are also some typical problems or caveats that people are just encountering. So it's just a book about all of this, experience of this .NET ecosystem on that field.
Yeah. So does this mean, if I understand this correct, Microsoft did not, or the .NET team did not go down that route like Java did, where you have a lot of different configuration options, so you can tweak the Java memory management based on your own need, but it's more the opposite, where the .NET memory management is still kind of like, you take it, you don't need to configure a whole lot, but over the years now, we have learned how to develop in a way so that .NET memory management works in an optimal way. So in a sense of, instead of configuring it for your needs, you develop based on best practices?
Yes, exactly. And as you said, it was a very well thought decision made at the very beginning of .NET, that it was designed that it doesn't require so many parameters to tune. Like in Java, there is a lot of flexibility. You can change GC, you have a lot of tunings there, a lot of parameters. But .NET decided to not take that path because they wanted to expose some very high level way of configuring GC, just to tune it for some typical scenarios, and doesn't put all these parameters and the choices on the developer. So yes, in general, we have in .NET some very high level way of configuring things, but still there are some patterns that we should be knowing if we want to write a memory aware software.
Mm-hmm. Hey Andy, this sounds a lot like when we always used to talk about things like throwing a framework into something. The classic example was always using Hibernate for JDBC connections, right? Where you're going to throw this package in, you're just going to let it do its thing, and you're going to ignore it. But what really happens in the end is, if you don't know the ins and outs, the pitfalls of it, you can get yourself in a lot of danger. And Konrad, it sounds to me like that's exactly what you're saying. .NET memory management works really good. However, there are a lot of ways in which a developer can use it in the wrong way, which can expose maybe, let's say, flaws or just limitations on how it works, which then gets you into memory trouble.
Exactly. I'm not sure if you know such law coined by Joel Spolsky, which is a law of leaky abstractions, that eventually every abstraction will leak and will hurt you somehow. And it's exactly like that in .NET memory management. In every automatic memory management ecosystem, the memory is kind of abstraction of the infinite memory, in fact, because we are, for example, only allocating objects and doesn't care about releasing them. So it's a kind of abstraction of infinite memory, yes. But in the end, this abstraction will eventually leak. And for example, out of a sudden, it turns out that there is something like memory leak in a environment which theoretically is releasing memory. So people are sometimes surprised that something like that may happen.
Yeah. And Andy and I, we've had several podcasts in the past, like way back, if we go back to the beginning of the podcast, where we would like to talk about, where we talked about some of our favorite anti-patterns, some of them involving .NET, some involving Java. But what I really, and I'm hoping, Andy, this is where you'd like to go with this as well, is let's hear about some of these really great anti-patterns that you're addressing in the book, because I think those are usually really fun to hear about.
Yeah, so I mean, when someone is asking me or other people related to the performance, what they should do and what are the patterns or anti-patterns, the first thing that we are saying is to measure, because and the rule which sounds Azure merely, because without measuring we don't know even we have any problem. Without measurement we don't understand our software, we don't know where is the problem and whether we should control something more to don't have this problem. So the very first thing, the very generic one, without even going into the details, I would put here that we should simply measure things to know what our system are doing in the context of memory management, for example. So the very first pattern is to measure, not even touching the code.
Yeah.
So, but what do you measure? What are the key things that people need to look at? Are these the classical performance counters we've been looking at for all the years, or is this anything where you say, man, I would wish that every developer on .NET would at least measure these metrics?
I would put here the memory usage, of course, but also we should understand what measurement is most important. So a lot of people, for example, are measuring the total memory usage, not knowing that, for example, they are taking or not taking into consideration the fragmentation of the memory. So sometimes I was seeing memory usage of dozens of gigabytes when most of the space was empty, for example, and they thought that they are using a lot of memory. And the second measurement would be the overhead of the GC, because not only the memory usage is important, but how much the GC itself consumes the CPU, for example. And here obviously there are those performance counters that you mentioned, but the problem is that they are only supported in .NET Framework, the main framework used on Windows. And in case of Linux, things are getting a little more complicated, at least currently, because they don't support performance counters. But still, there are some ways how to measure it, for example, using ETW events. But still, those are the two most important measurements: memory usage and GC overhead.
Now, the memory usage, you made a comment on by segmentation. I assume you talk about the different memory generations. So I think, if I remember back to my days as a developer, there was generation 0, 1, and 3 in the large object heap. Is this still the case?
Yes.
Or that's okay.
Yes, it's still the same. It doesn't change, but recently the one thing changed here, because for so many years the threshold about which objects are landing in large object heap and in small object heap was constant. It was 85,000 bytes. And it was on so many interview questions to ask which objects are landing where. And only recently this threshold is configurable, so we will be able to increase, for example, this threshold above which objects are allocated in large object heap, and it is the only difference here.
So that's interesting. If you're running microservices, right, I would imagine that was probably taken into account for that, where you might not be dealing with the traditional large objects like you might have been dealing with in a monolithic application. So it sounds like that would be used. Do you find, I guess my question there is, do you find that in more cases people might tweak that setting down to accommodate maybe smaller bits of information they're working with in a microservices architecture that they may want to keep in large object, or the opposite?
Unfortunately, it can be only increased
okay.
due, I don't know, some design decision, maybe to maintain some kind of backward compatibility. We can only increase this size. So, for example, if we if we operate on a lot of big objects and a lot of them were landing in large object heap, we can avoid this situation by tuning this parameter.
Okay. So I was totally wrong.
But again, without measurement, we have completely no idea whether we will benefit or not. So in such scenario, we have to measure more, maybe less important things, but we should just know, for example, the distribution of our objects. How many of them are dying in generation 2? Or, for example, how many objects are allocated in large object heap? This is important because large object heap is not compacted, for example, so it can grow faster due to fragmentation, and also allocations on large object heaps are slower a little bit. So without measurement, we won't know whether we are only allocating in small object heap or only or mainly in large object heap or something like that.
Hey, and just for understanding, because you just said, let's measure how many objects die in generation 2. So these are basically objects that live long enough to be promoted into generation 2, but then eventually get garbage collected. So these are very long living objects.
Yes.
And I assume these are good candidates to figure out, why do we keep them alive so long? What's the reason? Because I would assume you want to actually try to minimize the lifetime of objects, correct?
Yes, absolutely. One of the most common anti-patterns in the development is to introduce something which is called midlife crisis. So we are because garbage collector is designed in a way that most efficiently handles objects that are either living very shortly or living very long. But the most non-optimal way to handle object lifetime is when they are living long enough to go to the generation 2, but suddenly after a very short time they are just should be garbage collected, and they are just there for a very short time. So it's like promoting them to generation 2 only to garbage collect them there. And because garbage collection of the generation 2 is the most expensive one, we should avoid it.
That's awesome. So, I like the term, the midlife crisis. I have to.
Yes, it was yes, very funny name. But in general, yes, it's one of the most typical anti-patterns, and there are ways to measure it. For example, PerView tool has such report that shows what objects are dying in generation 2. And this is a good question. Why are dying there? Maybe we should pool them to have a pool of long-living objects and not to recreate many objects just to die in generation 2.
Really interesting.
Wow, that's pretty cool. I had another question on measuring garbage collection, because we talked about this earlier. So memory usage makes sense, generation 1 to 0, 1 to small and large object heap. And now garbage collection. I remember there were metrics around number of activations and number of, and like suspension time or total time. Is this, do I remember this correctly? So what type of garbage collection metrics itself are important to watch?
One of the in fact, from the garbage collector itself, two metrics are most important. One are those pauses that you are saying about, because there are some phases, even in concurrent GCs, there are some phases when just every thread has to be stopped. And this is obviously not very well from the perspective of performance, but because our application is being stopped for milliseconds, for example, hopefully only for milliseconds, so this impacts the throughput and the performance of the application. But also we can look at the CPU usage, because there are also such anti-patterns, and I see in such scenarios on production that theoretically everything is fine, application is running, there are no memory leaks, memory usage is stable. But when we look at the overhead of the CPU overhead of the GC, we see that most of the time what only is being done by the application is to do GC, because GC is so busy reclaiming memory. Because, for example, we allocate such a lot of so many objects that GC is so busy reclaiming memory after them. So the CPU overhead of the GC is also important.
So I would assume this is another anti-pattern, as you just said. It is allocating too many very large objects that then need to be garbage collected. Is there another pattern name, like the midlife crisis name that you have here?
Not so fancy, just rather not allocate.
Okay.
I mean, avoid allocations, no matter whether it is about small objects or large objects. In general, avoiding allocations is one of the most important performance tips, tricks which we can use to make our application faster, because allocation by itself costs something, because GC has to find space for it, let's say that in general. And then when we allocate, obviously, GC will have to reclaim memory after this object eventually. So not allocating is always the best choice from the performance perspective. And in fact, I dedicated dozen of pages about this, what are the common sources of allocations and how to avoid them, because as we were saying before, it is very convenient abstractions that we have. Abstract of infinite memory we can always allocate. So people learning C#, for example, only are aware of newing up objects. They even don't care about something like that the memory should be reclaimed. Yes. We are not learning people about this. And then out of the sudden, people are discovering that allocations are costly and we should avoid them. And which for many people is quite surprising, that we should start to think about avoiding allocations.
Go on, Andy.
Go ahead, Brian.
I was just going to ask how much... we know there's obviously the full-fledged .NET that runs on the traditional Windows ecosystem. And now in the last few years, we've had .NET Core, and you've already addressed a little bit about, how some of the monitoring doesn't really work on Linux because you can't get into that view. But in terms of, the 1,000 pages of your book and all the research you've done in there, in terms of the memory operation in .NET, is it the same in the full-fledged I don't want to say full-fledged, but in the full version of .NET versus the newer .NET Core? Are the memory management components the same? I figured the anti-patterns are going to be the same, right? Because anti-patterns typically become somewhat universal. But is .NET memory management the same across full stack .NET and .NET Core?
Yes, in general, yes, because when .NET Core was created, the code of the GC was just, let's say, copy-pasted to the .NET Core, and it's only 40,000 lines of codes. But yes, it was the same GC simply. So the whole implementation details can be directly translated between those two .NET frameworks that we have currently. There are some minor changes on the level of the API and the communication with the operating system, because some things was not so easy to translate between Windows API and the Linux API. So there are some things done a little bit differently, but the influence of those of those differences is very small, in fact. So there are some very, very small differences in the implementation, but the whole algorithm, the whole thing is the same.
Okay.
And the main difference is from the perspective of the, let's say, regular development is the monitoring thing, because
right.
during those over 10 years of .NET on Windows, there a lot of tools and good practices were created, smaller or bigger, commercial, non-commercial tools for supporting monitoring and diagnostic of .NET. But on the Linux, things are a little bit worse currently, unfortunately, but I believe it will be changing because .NET Core on Linux is getting more and more popularity, so things will be just, we have to wait a little bit for probably.
So Andy, that brings to mind, we used to joke, or I used to joke at least, especially when we talked to Donovan Brown at Microsoft, how you could, in theory, use .NET Core for free, running it on, not paying you don't have to pay a license for .NET Core. You could run it on a Linux OS, which you don't have to pay a license for. And then if you're running it in Azure, the only thing you're paying for is the compute. But in a way, and I don't think they did this on purpose, but obviously the one way that helps keeping it on Windows, right, is the fact that you lose that monitoring, or a lot of that monitoring capability, which, as we all know, if you've spent any time in applications, monitoring your memory is really, really important. So I think short term, it helps them probably keep people on Windows for it.
Yeah, or it's obviously a great way for tool vendors, and obviously that includes us as Dynatrace. I'm sure there's many other tool vendors out there to kind of fill the gap, right? I assume so.
Yes.
So Konrad, I assume there are ways, as you said, to get around some of these shortcomings, either through, I think you mentioned ETW, but I'm sure there's other ways on how to get performance metrics that are currently maybe not provided in the same convenient way as it used to be the case on Windows?
In general, ETW has been translated into LLTNG's infrastructure with something abbreviated as Linux tracing for Windows next generation or something like that. But in general, it's ETW infrastructure on Linux. So .NET Core is using it on Linux to provide something very similar to ETW on Linux. The names of the event is the same, so it's good. The major, in fact, problem is, for example, that, and it is very important from diagnostic point of view, for example, that on Windows, ETW events can be augmented with stack traces, and it is a very powerful thing, for example, to see when each exception was thrown. And on Linux, LLTNG infrastructure doesn't provide information about stack traces. So this is a quite big limitation, because for now, for example, events like allocations or events like exceptions doesn't provide on Linux the stack trace. This is currently the most sad thing about diagnostic and monitoring of Linux.NET Core.
Wouldn't you be able to do it through an instrumentation-based approach, where you would instrument, let's say, the constructors of objects, and then just capture the current stack trace? Would that be a workaround, right?
Yes. But the main difference of ETW and this counterpart event infrastructure on Linux is that it is very lightweight, so it doesn't introduce almost any overhead. When we start to think about instrumentation, obviously we are getting more and more overhead. So we should balance here what we want to monitor and at what cost.
Right. I mean, that comes back to a topic that we have been addressing over the last couple of years. Always the balance with what level of visibility do you want to give for what particular cost, and that's the same whether it's for end-to-end tracing, as what we've been doing for years, or for deep dive memory instrumentation. I agree with you.
Yes.
Very cool. Let me ask you, so there's a lot of change obviously going on in the .NET ecosystem, in the .NET community. Is there, I'm sure you are very well involved and very well connected with the core development teams here?
In fact, the team of the GC team of the .NET was reviewing my book, so I get quite in touch with them. What was one of the most pleasant things for me, because those things are changing so fast that I was afraid that my book will be outdated before finishing. So getting in touch with the team which is developing GC, for example, in .NET was a very, very convenient thing for me. And thanks to that, I know a little bit that what will be changing, what was changing. I have a possibility to include it in the book, for example. But still, even now, after the book publication, it's getting outdated day by day a little bit, because as you said, things in .NET are changing so fast, especially on the field of performance, that it's really hard to catch up, especially when publishing book.
Yeah. By the way, I would assume your book is also available as an electronic version and not just hard copy.
Yes, it is.
Yeah, well, and
all these things that are... Sorry?
I said that gives you an easier way to do continuous delivery, meaning you can continuously update your content, and hopefully your consumers, your readers that buy it online or in an electronic version can get the latest updates from you.
And I wonder how much the electrons weigh for the ebook.
Continuous publishing, let's say.
Yeah, that's good.
But you are aware probably about all those things, especially the more and more emphasis put on structure usage, on stack allocations, on using span of T, and all of those things that are going to happen and is happening currently in .NET ecosystem. Those are great things because they really opens new possibilities. And I have never seen so big emphasis on performance from the .NET. In fact, obviously it was good. Obviously it was working good. It was fast enough. But what is happening now? It's really nice to see all those changes.
Yeah. Mm-hmm. Let me ask you a question. One of the things I've experienced in when I interface with developers, especially .NET developers, is a partial fear of memory and an attitude of, well, it's all handled. There's nothing I could do about it, so I don't really think about it, right? But as we see, obviously, there are anti-patterns or memory problems that come up. I think sort of an anti-pattern in approaching memory, especially in Java where you have a lot more control, is instead of learning about memory and using it well, people just try to tweak the memory settings to make it run as good as it can, right? So it's fixing the way they're trying to tackle it by changing the way memory is managed, how GC is run and everything, instead of really getting at the core of their memory usage. As we see in .NET, you really don't have too many controls, but yet these anti-patterns come up a lot, right? And the only way a developer can figure out how to avoid the anti-patterns is to really, start really embracing the concepts of learning how memory is used and really diving into it more, which, as I mentioned when I started this, is kind of where there's a bit of fear. So obviously, one of the resources that are available will be your phenomenal book. But in terms of advice to developers to say, stop fearing memory and embrace it, what do you have any advice of, like, even just like a very getting started? How do you ease them into really starting to pay attention in memory and really looking at that as a discipline?
I would return to the measurements, because what can they do is just to measure on production, for example, or even on the development station, what is this usage, to just have some kind of clue how it looks like.
Right.
And then just to and especially about this, for example, distribution of generations, what is allocated where and what is dying where. And then probably they will start, they should think about those allocations to start to be at least to be aware of what and where they are allocating, whether they are just whether they are only aware about those allocations, or maybe completely not, and they are just writing code without any things about without any thinking about it. So allocations is the second one. To think where they are allocating things. For example, whether they can use some kind of pooling to not allocate things, whether they can use struct, and why structs are good also would be very nice for them to understand. So it would be those things, I believe, from the code perspective, to be aware of the allocations.
Right. So in general, it sounds like even the most basic piece is just observe and monitor your memory, just so you're aware of it. And the more you're aware of it, the more you'll probably start looking into some of these other things.
Exactly. To the specific problems, for example.
Yeah. I mean, because I can't tell you how many times I've heard .NET developers, when I've pointed out some memory issues, and they're like, well, .NET handles the memory. There's nothing I can do.
Yes, you're just exactly. And exactly this were the questions about, for example, my work on this book. Why I wrote a book about something which is automatic and it should work.
Yeah.
Obviously, as we are all constantly repeating today, there are some cases when we should simply know more about what are going. What and how the things are going is underneath. So yes, exactly. And by measuring, I'm just saying about this because it's the best thing. Of course, we can learn a lot of rules about memory. We can learn a lot about internals of the GC. But in the end, the most important thing for the particular developer will be something which directly relates to her product. So it's the best to just look at its own product and see whether we have problems there or not.
Hey, I was just browsing on your pro.netmemory.com website, where people can buy your book, but there's also a free poster that is the .NET Memory Management poster, which I thought is pretty cool for people. It's a great visualization of all the different memory spaces. I think you do a great job here in actually explaining, even though it's very crowded because there's a lot of stuff going on.
Yes.
But it's a great way to get an overview of everything that is related to memory. So everybody that wants to, we'll put the link probably on the podcast page as well. But for people that want to find it right now, pro.netmemory.com. Pretty cool.
It would be great. It's designed to be printed and hanged on the wall or somewhere, just as a reference to show what are the regions of the memory in .NET process, what are those generations, and the concept of roots, what are the roots of the objects, so what is keeping objects alive, for example, because we didn't touch the problem of memory leak here, which also can happen in .NET. So a lot of people are just surprised that memory leak may happen in the environment which should reclaim memory. So all this is visualized somehow on this poster. Yep.
Yeah, it's a great little poster.
And I think we shouldn't go into every single pattern and all the details, because we want still people to buy a book.
Yeah.
Oh yes, only 1,000 pages. So
I'm hoping there's a lot of patterns in there, Andy.
For days.
Yeah. Very cool. I do have one last question, because I'm just browsing through the chapters of your book. Chapter 15, Programmatical APIs. And is there one example or one use case where it makes sense to trigger the GC through the API? Well, give me one example.
In general, the obvious rule is do not call it, of course, but there are very rare cases. For example, when let's say GC has some heuristics and measurements about the memory usage, but obviously in your program you know better sometimes that, for example, you have just allocated a lot of data to be processed. and those data are just not needed anymore. Let's say we are pre-processing something to generate new level in a game or something like that. So we loaded a lot of data and it won't be needed anymore. So it doesn't make sense to wait for the GC to notice that those data are not needed anymore. We can trigger it and just to get rid of those not needed memory as fast as possible. So it would be one of the scenarios when you explicitly know that you have allocated a lot of data and you don't need it anymore.
Mm-hmm.
And this is one of the most common scenarios that we can think of.
Yeah. Very cool. Hey, Konrad, is there anything else to kind of close this episode? Is there anything else that people should definitely need to know other than obviously, looking at your book?
I believe that I really encourage people to learn about .NET memory. I'm not directly referring to my book, but I have a lot of contacts with .NET related people, with .NET developers, giving trainings, for example, about architecture, not about .NET memory. And I see how many people is surprised that it is even a case that they should know about .NET memory management. And I believe they should, because we really are not aware about the overhead, for example, that we can introduce by the GC itself. So I really encourage people to find information about it. There is a lot of blog posts, a lot of videos about .NET memory management and .NET GC. So just took any from the internet and start reading. Not necessarily from my book, because it's a lot of work to read it, but any blog post about it, I believe, will be just enough to start this journey, because obviously in 18% of our development maybe it's not very necessary. So when we are starting to learn someone to develop in C#, we just don't want to put too many information about such things. But when we are developing and when we are earning money for from C# development for years, I believe it's kind of professionalism to know such things, how things are working, how they are influencing the efficiency, the cost of the software which we are writing. So I just encourage people for searching for such things. And one more thing, because a lot of people are saying that memory is cheap. So currently memory is cheap. There is such phrase that I'm hearing quite often, but it's obviously not very, from my perspective, it's not very true, because there is always someone paying for this memory. Even if we are using, for example, serverless, we are paying for something like metrics for something like gigabytes per seconds or something like that. So the more memory we are using, it directly translates to the more money we are spending on this. So this phrase that memory is cheap is really very oversimplifications of things, I believe. And we should, it's the same about performance in general, but the memory is one of the most influential parts here. So what I am trying to say simply is that I can encourage all listeners to find information about it.
Yeah. Yep. And I think one of the times you usually hear a groan from problem analysis is when people realize there's a memory issue. Because then it's, well, who knows enough to really dive in to understand why that's happening, right? Especially, again, when we go back to .NET, .NET takes care of these things for you. So we're obviously violating some sort of rule or some sort of way that .NET's going to handle the memory to actually create a problem. And finding someone who knows enough about memory utilization, how it all works, is always the hard part. That's what the developers don't like to necessarily spend time on. So I think it's great that you encourage people to learn about it, because it'll make someone really valuable. But But
yes. And there are two aspects of it. There's aspects of diagnostics that, as you said, developers are not necessarily very keen of, but also there is an aspect of writing memory-aware code. Yes, and this is quite fancy because there's a lot of very interesting things happening there. Writing performance and memory-aware code is just fun for me, for example, because it's something demanding and something that you have to think a little bit about. So this is an interesting aspect, for example, for the regular .NET developers, let's say like that. And all those structs, for example, why structs are useful. A lot of people are not using structs at all because they are not seeing any advantages of it. And in fact, there are many. So one of the things that people listening us can start to, from where can they start, is to start about reading why structs in C# can be useful, and it will just begin some journey for them, I believe.
Awesome. So, hey, Andy,
Mm-hmm.
do you think it's time to summon the summarator?
I think it's time.
Absolutely, yeah.
All right.
Do it now.
All right. So, I mean, I have to say, I think the last couple of minutes were already a great reminder of all the stuff Konrad told us and what we need to do. I just want to highlight the things that I've taken away is that rule number 1, measure, because obviously what you don't know, you cannot optimize. Rule number 2, understand and minimize your allocations, right? Because we can reduce the overhead that memory and garbage collection especially has by simply allocating less. And I really like some of the patterns that you just talked about, especially the first one, which has a very, let's say, interesting name, the midlife crisis pattern, where we want to avoid objects that get promoted to Gen 2 for a very short time. So basically just getting promoted, just getting old enough to then kind of, get garbage collected. I really hope that a lot of people will start thinking about memory management in .NET from now on to really start writing memory-aware software. I like that term a lot as well. It seems that maybe the analogy would be only the best developers are like the best, let's say, race drivers, right? The best race driver is the one that not only knows how to drive the car, but actually understands how his car actually works on that particular track, how the engine works, when to shift gears. And I think this is the same with engineers. We need to write, in this case, our code so that it can optimally run on the underlying engine, which in this case is .NET, with a very, kind of predefined memory management approach. And the more people that know about it, the more people that are aware of what impact they can have when they write memory-aware software, the better it is. And a great start is the book from Konrad, and you can find it on pro.netmemory.com.
Excellent, Andy. Thank you very much. I got nothing else to add to that. I think you summed it up perfectly. And Konrad, you have one other thing I noticed on your book's website, or the pro.memory.com, is you're also available for online consulting and on-site trainings for .NET. So if people are looking to maybe bring up some of their employees and get them to dive into this .NET stuff, the memory stuff that is, you're available for that, it looks like, correct?
Absolutely. I'm more than interested in doing this kind of trainings, on-site consultancy or online consultancy. There is a lot of interesting things to learn, to teach on that field. So absolutely.
All right. And if people want to follow you, see what's going on with you, are you on any social media that they can follow?
I'm a fan of Twitter, so there is a handle, Konrad Kokosa, simply. Probably we'll link something
Yes, we will.
in the blog post. Yep.
Perfect. I just wanted to thank everybody for listening today. I think this was a great topic. I always love when we go back to these kind of what I might call the basics, but they're always evolving and always really, really important to never forget about. So thanks everyone for listening. If you have any questions or comments, tweet us at pure_DT. Or you can send us an email at pureperformance@dynatrace.com. If you have any stories or would like to be on the show, also get in touch with us and we'll see if we can make that work. But for me, I want to say thank you and goodbye, everybody.
Goodbye.
Goodbye. Thank you.